In this video, we are going to discuss projections of a cylinder with the condition axis inclined to HP and parallel to VP. Let us see a problem. A cylinder of diameter 30 mm and axis length 50 mm is resting on the HP on a point of its base such that its axis is inclined at 45 degrees to HP and parallel to VP. Draw its top and front views. In this problem, the axis of the cylinder is inclined to HP and parallel to VP. A cylinder does not have any base edges or base corners, so it is resting with the ground with a point of the circular base. Since the axis of the cylinder is inclined to HP, in the first stage, we have to consider that the axis is perpendicular to HP. When the axis is perpendicular to HP or ground, the cylinder may rest on the ground with its base. At the same time, the base of the cylinder will become perpendicular to VP. The base shape of the cylinder, that is a circle, can be seen in the top view or plan. Hence, we should draw a circle of diameter 30 mm below the XY line as planned. Since the cylinder does not have any base corners or base edges, for our convenience of projections, divide the circle into equal number of segments. Divide the circle into 8 equal parts and name these points as 1, 2, 3, 4, 5, 6, 7 and 8. Cylinder has two bases, one at the top and one at the bottom. Divisional points of the top base can be named as A, B, C, D, E, F, G and H. Project the center of the cylinder as the axis of the front view or elevation. Mark the height of the cylinder 50 mm on the axis. Project the extreme ends of the circle and draw elevation as a rectangle. The base side of the rectangle is equal to the diameter of the circle. Now project all the divisional points of the plan and mark the corresponding points in the elevation also. Bottom base points are 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash, and the top base points are A dash, B dash, C dash, D dash, E dash, F dash, G dash and H dash. By this, the first stage of projection of the cylinder for the condition axis perpendicular to HP and parallel to VP are drawn. But in the actual case, the cylinder is resting with only a point of its base on HP. When a point of base of the cylinder is on HP, the axis will be inclined to HP and the inclination is given as 45 degrees. So the elevation is to be tilted for the given inclination. When the axis is inclined, the extreme end generators will also be inclined. In the second stage elevation, draw a 45 degree inclined line. This line is the vertical side of the rectangle of the first stage elevation. Based on this 45 degree inclined line, reconstruct the rectangle. Mark the top base points. And the bottom base points. Now to draw the plan of the second stage or the final plan, project all the top and bottom base corners of the second stage elevation. Similarly, project all the points of the first stage plan. Trace and identify the corresponding points of intersection of the plan. The circular bases can be seen as an ellipse in the second stage plan. The top base is fully visible, hence should be drawn as dark. The bottom base only the outer half will be visible. Hence, only the outer half of the elliptical shape should be dark. The inner half will be invisible, hence should be drawn as dotted line. Though a cylinder does not have any longer edges, the extreme end generators are visible, dark lines connecting this ellipse. Thus, the projection of the cylinder resting with a point of the base on HP and axis parallel to VP are drawn. Finally, show the dimensions.